Welcome to homework.
So we were asked to prove that if a plane mirror is rotated through an angle alpha, then the reflected beam is rotated through an angle 2 alpha, and show that this is a reasonable result for alpha equals 45 degrees. So I drew the red line here as our point that's being displaced by some value alpha. So m goes to m prime and t goes to t prime, the dotted lines. And then we have points P, N prime, R, and R prime, where R and R prime are that reflected ray here. And all the angles are labeled in blue. So we have angle alpha, angle I, and then we have an angle there, R minus alpha, between N prime and R. And so we're going to use these triangles here to go ahead and work out this problem. So when ray PQ, which is the incident ray, P to point Q here, point Q is where everything is meeting. So when ray PQ is reflected in the QR direction, we have angle, let's go ahead and get a black marker here. So we have angle PQN is equal to the angle NQR. Or in other words, the angle of the incident is equal to the angle of the reflected. Okay, so when a mirror is rotated by some angle alpha, the normal ray is also going to be rotated by the alpha. So the new incident angle, which we call I prime, is going to be equal to the incident angle I plus alpha. And the new reflected ray, R prime, is going to be equal to the angle P, Q, M prime, which is equal to the angle R prime, Q, T prime, which is equal to 90 degrees minus alpha plus I. So, therefore, the angle N prime Q R prime, that angle would be equal to 90 degrees minus R, little r prime, which was written above. So it'd be 90 degrees minus 90 minus alpha plus I. And then this all would be in a larger parenthesis. It'd be 90 minus that value. So this comes out to equal alpha plus I. So therefore, and we can start a new page for this and keep track of everything that we're doing here. Therefore, we have the angle RQR prime. So the displacement and the reflected angle is equal to the angle of NQR prime minus the angle N prime QR. So we can plug those values in. So NQR prime was alpha plus I. Minus, and then N prime QR was R minus alpha. So what we end up with, so this all comes out to equal, room on top there, so let's write it here, 2 alpha, so 2 times alpha, plus I minus R. But in the beginning, we said the angle I, little I, is equal to the angle little r. That's what we found right here. I'll just point to it with an arrow. So since we found that, we can conclude that this is just equal to 2 times alpha, because I minus r would cancel out. So this is equal to 2 alpha. So therefore, we can conclude that the angle r times q times r prime is indeed equal to 2 times alpha. And if alpha is equal to 45 degrees, so if alpha equals 45 degrees, then the angle r times q times r prime is equal to 90 degrees, which is reasonable. So let's just go ahead and box all this in as our solution for the question.